Okay, morning everyone. So my name is Ben Roberts. For those of you who haven't met me, I'm head of solutions here at Toca. So I work with clients across all the various sectors that we work in wealth, in finance, in law, in the NHS, in health. So all sorts and types for all sorts of different use cases, employing the platform in a variety of ways. So ranging from sort of robotic process automation through to our API integration through to full stack application design and build. So Toca is a very, very powerful platform, allows you to move very, very quickly, as potentially you would have seen if you've worked through the community or had access to any of the sort of training environments or the preview environments. Today, what I'd like to do is sort of build a foundation in the platform. So we'll cover a couple of those things I mentioned: RPA, API integration, application design, in a fairly sort of structured way. And hopefully by the end of the session, you'll have a solid baseline in how to build applications both in the back end and the front end inside of Toca. So what I'll do here is I'll start by sharing my screen, and we'll first look at the backend side. So we'll look at the automation. We'll look at how you can use activities to build units of automation, workflows to chain them together, and data stores to persistently store data. And then we'll move to the front end side. We'll look at the applications. We'll look at how you can build responsive applications for different viewports, how you can inject data into your applications, how you can add interactivity using in-page logic and browser-based sort of variable storage, and also how to theme, deploy, and authenticate users against those applications. So that's sort of the baseline that we'll try and cover today. So let me share my screen and we will get started. Okay, move that up there. Okay. So this is the Toca platform. Broadly speaking, as I said, Toca is split into two halves. So you've got the automation side and the application side. What we'll do is we'll start by looking at the automation, and then we'll move across to look at the application. Now, we'll start with some of the relatively basic stuff, and then get hopefully a little bit more complex as we go. What I'm going to suggest as well is that we split this session. It's a long old session. It's 3 hours. So we'll split it into 3 pieces separated by a 10-minute break at 5 to and 5 past the hour. So we'll go until about, in my time, we'll go until about 5 to 11. And then we'll do the same, take another break at about 5 to 12. And then we'll wrap things up. So let's start on the automation side then. So I'll create a new automation project here. And this brings me into my automation project overview. So there are 4 sort of key entities that I'm working with in the automation. You've got activities, which are essentially small units of automation. If you're from more of a technical or coding background, you can think of activities as functions. Essentially, they have the ability to take data in via arguments or inputs and output data via outputs or by writing to a database or data storage. And so activities are really the workhorse or the horses of Toca, if you like. Workflows are then where you chain those activities together into cohesive business processes or back-end processes. So just as you'd string horses to your carriage, your workflow, you're stringing activities to your workflow. And the advantage of doing things in a workflow is that you can schedule workflows. So if you're doing any sort of automation or integration that involves regularly pulling data, let's say, synchronizing with an external data source, you can schedule your workflow. Workflows also allow you to do event-based triggering. So you can call workflows like you would call an API using listeners and also connectors, which we'll cover as well. And that also allows you then to actually connect your automation up to your applications, because your applications can call into your workflows and execute them and then sort of return data to the front end. We've then got data stores, which is where you can persistently store data. There are two underlying table technologies here. There is a SQL-based table structure, which allows you to basically build relational tables and store data in sort of large volumes. There's also unstructured data storage here, so you can throw files into your data store, images, passwords that are encrypted at rest, all these sorts of things. And then schedules, as I mentioned, can be used to schedule your workflows. So some of you may have seen, we'll start with the activities. Some of you may have seen some or all of the first activity that we will build together, but hopefully it will be a good sort of foray and a good way to explain some of the basic concepts and sort of best practices that you should probably follow when you're building activities in the platform. So I'm going to start here with a classic, which is probably my least favorite demo ever because I've done it about 1 million times, but it's a demo here, an activity that will go and grab a set of FTSE data using robotic process automation. So we'll start there and then we'll move across and look at table manipulation and APIs and all this good stuff as well. So let's create a new activity. Ideally, you'd give each activity build a meaningful description, and then you can assign the activity bot. There are two types of bot, and they are a stateless type, which you can see it's presenting to me here, and then a GUI type, which is a specific bot. So every time you load an instance of the platform, you'll see that so many bots are loaded with it, and these are the workers that are going to execute the automation that I lay down. So this is a GUI bot, so I can interact with it. If I click here, I can interact with the screen. I can basically interact with it as my own desktop environment. I've also got the ability here to upload files and download files from the bot and push and pull clipboard data as well when I'm setting up my automation. So we'll be using this later. But when you register with a given platform, then an admin should assign you a bot. So if you're administrating any particular Toca platform, you can see here you've got your users, and then you've also got your bots, which you can assign to all of your various users here. We'll come back and have a look at the admin panel potentially later as well. But those are our GUI bots. That's that sort of second type of bot that we presented when we created the activity. The other type of bot that we've got is a stateless bot. And a stateless bot essentially is every GUI bot runs a stateless service in the background that allows jobs to run in parallel and without storing any state. So you would use a GUI bot for, say, doing RPA, as we'll do here, but you'd probably use a stateless bot for doing any sort of table manipulation or API interaction, or if you're setting up some sort of back-end process for a web application you're building in the application side, you probably want to use a stateless bot because they can run tasks concurrently. We'll start here with a GUI bot, and we'll create an activity. So this is the activity designer. It's a fairly straightforward layout here. We've got a canvas over here on the left where we can add our actions. We've got a console over here that will show us what we're executing, and we've got a preview of the bot screen over here. Now, by default, when you build any entity in Toca, you build in the draft state, and once you make changes, you can then publish your changes to a publish state. The advantage of doing this is that you can separate, to some degree, your development and your changes that you're actively making and your production processes. So we'll be working in draft by default here, but I'll show you how we publish and how we use that inside of the workflows and the apps, etc. It's just something to bear in mind for the moment. Up here, you've got a little view of who's working on any given activity at once. And in fact, if I duplicate this browser here into another tab, you'll see, hopefully, when this loads, there we go. You'll see that there are now 2 instances of my training at Toca.io persona working in this activity. The reason that this is important is that if I start to make changes here, so I'll do this, and we'll do things a little more rigorously in a moment, but if I make a change here, you'll see that I get a message on my other screen saying activity has been updated by another user, and indeed here it is. If I start making changes here, it will also lock down the activity so that only one person is working on it at once. And in a sort of a little bit like you'd have Git version control, it's not exactly the same, but this basically ensures that you don't overwrite each other's changes. You're working collaboratively inside of any given activity. So we'll close down that other window. That's fine. And we'll remove these actions for now. Undo redo. Ability to bring the GUI bot full screen if you're doing that interaction. Ability to reassign the bot up here as well and see what executions that bot is currently on. So if it's executing any other activities, and then save, and obviously the publish function, which I mentioned before. So to get started, what we probably want to do is pull all of the various actions that we want to use into our activity. Actions are essentially units of code that we've created for you, and this is what makes the platform low code. It's the fact that you can pull these blocks of code together, fill them with some basic configuration, and move very quickly as a result. We may have a look later at how to extend the actions inside of the TDK. But for now, I'm going to click on my More panel over here. I can pull all of the various action groups down to my bot. Okay, and you'll see that it populates the menu over here on the left. So there's a variety of actions. Probably the simplest possible action that I could demonstrate is something like a mouse click. So I'll just slow that down a bit. So if I add a mouse click to my activity, see it opens the configuration. I can select the action version I'm using up here. And then this particular action actually allows me to interact with the bot screen directly. So I can place my crosshair on the bot screen, and I can say perform right click at this specific coordinate. And if I run this through, you'll see that the bot runs a right click at this specific coordinate. So it's doing exactly as we told it to do. Now, mouse click is a fairly rudimentary RPA action, because let's imagine that I'd like to use this mouse click. In fact, just for the purpose of the demonstration, let's interact with the bot, and we'll add a file to the desktop. So I'll just add some test text here, test.txt. Okay, so we'll pop this text file on our desktop. Here it is. Okay, and let's imagine that one of the bits of RPA we want to do is to get the bot to open this text file. Now, the most immediate way, obvious way to do this is we could ask it to left double click on the text file. So I could ask it to target this text file and click on it and run, and you'll see it double clicks, and indeed it then goes to open up that text file. The issue of this, of course, is that if that text file moves, so if I move it over here on the screen and I ask it to perform that double click again, it's still clicking over here, but our text file is over here. So there are a variety of more sophisticated RPA actions, such as an image click, that we might use instead to intelligently find an image on the screen and then click it regardless of where it appears. So this image click, if I drag my cursor, you can see I can adjust the image that I'm looking for. Oh, I've lost it there. So let's try and grab that test text again. I can set a region that I want to search in, so I can restrict the region to this portion of the screen, and this is common across many of the actions. I can also search for an image and then offset the click that I perform by using these coordinates. So I could, for example, decide, I could say, look for this, but actually click over here. Clear that for now. Set whether it's color sensitive, and also set the threshold, i.e. how similar I need that image to be to the original image that I captured in order for the bot to click there. Again, I can set my click type to left double. If I run this image click through, you'll see again the bot intelligently finds the image on the screen and it double clicks. So image click is a pretty powerful one if you're doing any sort of robotic process automation on desktop-based applications. There are related actions in the vision group over here on the left that I use. So there's an image search, which you can use to delay automation until a particular image is loaded on the screen. There's an image do while, i.e. continue to perform a set of actions until you see an image on the screen or while an image is persisting on the screen. And there are also the image click and the image grid. So it's worth exploring some of the functions that you have over here. On a related note, I should mention that there are other actions like the OCR actions, if I can find them. They can be used not to search for images, but to actually search for text or click on text using, say, an OCR text click, an OCR search, very similar, and an OCR, say, grid to table. So you can take the tabular data on the page and convert it directly into a table that you can manipulate the platform. We won't look at all of these in detail, but it's just worth knowing that they're there. So I've managed to, let's drop our text back over here on the left. We may well use that later on. I'll remove these actions for now. And we'll start by doing a bit of browser-based automation because it's a very common sort of use case in Toca for doing robotic process automation. So as I said, I'm going to set up an activity that's going to go and grab some FTSE data, so some UK stock market data, FTSE 100. And we're going to pull that into the platform. And in doing so, I'll show you some sort of highlight or illustrate some concepts along the way. So the first thing that I'm going to do here is I'm going to identify the site that I want to grab data from. So in this case, it's this Hargreaves Lansdowne page, which has a summary of the FTSE 100. Momentum, it does appear to be running a little bit slow today. So you can see it's this market overview page here. In particular, what I'd like to do is grab this table down here and pull it through to the platform, perform some manipulations, and ultimately present it inside an application. So what I'm going to do is grab my URL here. We're going to find our browser group in Toca, here it is, and we're going to open a browser up to that URL. So I'm just going to paste it in here, give the browser a name. We've got some other options here. And we can save, and I can run the activity, and you'll see indeed the bot opens up that browser. Now, as I'm performing all of these actions, you can see my console is populating down here. So this gives me a log of all of the automation that I'm running as I'm developing this activity. So you can see our mouse click, you can see our image click. And if I click into any of these, you'll see it gives me quite a lot of detail about what time the action ran at, how long it took, whether it was successful, and then some feedback as well that I can use later in my automation. So you can see the image click, for example, it returned a status, this Boolean here, which was a truthy value. So it managed to find that text field we laid down earlier. Tells me where it found the field. It even shows me a picture of where it found it on the screen. And so these are all variables that I could decide to use in subsequent automation to affect the flow. For our browser action, it's a little bit more restricted. It tells me the alias and the process ID, so not much going on here. But it's just worth knowing that as you populate things here, you can see it appear on the console. You can filter down the console, so you can search for specific actions, for example, if you're going through a slightly larger activity, like so. Oh, just managed to delete that. You can also, if you click the little green arrow here, you can actually highlight the action or inside of your activity as well. So if you've got a lengthier activity, you can use this to find specific elements. Okay, so let's pull our bot screen back up. Okay, so we can see what's going on. Next thing that we'll do is use another one of the browser actions to clear this cookies notification, which has appeared over here. So again, variety of elements to use here. So it's worth playing with all of these if you're looking to do any robotic process automation on the browser. The one that we want here, and the one that's probably most common when you're doing any sort of browser-based automation, is get web element. So you'll see it automatically populates with that FTSE alias that we set up for our browser. And what this allows me to do is either grab individual elements of data from the page, or interact with those elements. And it does that by looking at the actual HTML on the page. So again, if I use my crosshair, I can target this accept button. You see it returns a big list of all the browser elements it thinks I can be clicking on. So if I hover over these, you'll see it sort of shows me all these different areas. So I could say, select this button. You can, if you like, hard code the X path, which is just browser parlance for where the element lives. So you can see this particular button is in HTML, body, div, all the way down to the button. So you can actually code that if you like. And the interaction here, I'm going to select is a clip. So I'm just going to click on this button. Worth noting, though, again, that you could do a mouse over. So you could just hover. You could submit a form using this. You could also send data using send keys if you're populating fields of the form, or you can grab data out of the element with data only. In this case, I'm going to use a click. Now, there is a potential when you're building any sort of RPA that a website or an application isn't necessarily going to perform as it does as you're developing. So this is something to keep in the back of your mind when you're doing robotic process automation. And you need to think about the steps that you put in place to mitigate any changes in behavior. So in particular here, this cookies notification might not always appear. And at the moment, this action is set to a timeout of 30,000 milliseconds or 30 seconds. And so what this means is this bot is going to sit and wait for this cookies notification for up to 30 seconds before it gives up and moves on. And obviously, if this notification never appears again, because it's been cleared once by the bot, we don't want this automation delayed by a full 30 seconds. So this is a good example of where you need to be mindful. I might set this down to say 5 seconds or even 3 seconds if I think the page is going to be particularly responsive. I've also got options here in terms of what I'd like what errors I'd like to be thrown based on the behavior here. So as an example, you can see error on timeout is currently set to false, but I'd actually like to set this, and given it's a cookies notification, that's fine. If it doesn't find the notification, I'll leave it false, that's no problem. But if it fails for any other reason or errors for any other reason, then I'd like the activity to fail, and I'd like it to stop what it's doing because it indicates that something deeper is wrong. So these are flags that you'll find across most of the sort of the actions that you use in the platform. It's worth being aware of them here. So we will save that and we'll run get web elements, and you'll see a new message in the console has appeared. Here it is. There's my get web element. And you'll see, again, it gives me a bunch of info. So it tells me if it found the element, what the image was, where it found it, what text was contained if I wanted to grab that, and then any other related information that exists. You can see that this bot has now cleared this. Now, as I said, all of this information is pretty useful to me because I can use it to vary the subsequent behavior of my automation. So as an example here, what I might like to do is just throw out if the element is found, I might like to throw a debug log out to the console just to detail, capture specifically, say, the text that it found when it clicked the button. And so I can use this element found flag in order to do that. If I look at the action over here, I can hit this info and you'll see it presents me with all of these outputs that I find down here in my console. So you can see it's showing me that image and the XPath it used and the text that it found, and particularly this element found flag. So if I look in my activity now for the flow control group, as an example, there's a range of functions here that I can use to iteratively perform actions or conditionally perform them. And in particular, what I'd like to use is this if to say if the button is found, then log something out to the console. So I can drag. You can either click on actions to add them at the bottom, or you can drag them into your activity. I can say if the element is found. And then I can find my debug, and in fact I'll use my search, find my debug. Again, I can drag that in, then debug, button was found, as an example. So now if I run these steps through, we can restart the activity, navigates to the website, it finds the element, and you'll see that in the console it reports that the if was successful because the condition was met, and you can see it's debugged, that value button was found. Now, a couple of sort of subtle things that I did there. The first is that I used this little X button here to pull the flag from get web element into this if statement. We refer to this in Toca as data chipping, and it's how you inject data from one place to another across the entire platform, both in the automation and in the applications. It's a really important sort of concept to master, or to be aware of. There is a slightly more advanced version of chipping, which we'll look at a little bit, which is sub-chipping. But essentially, if I want to take data from one action to another, or from a data store, or wherever it might be, I'm going to be using this little data chip button in order to do that. And you'll see now that I've mentioned it, hopefully you'll sort of see it absolutely everywhere. Dinesh, yeah, you got a question.
Yeah, Ben, one quick question. So, but what essentially we are trying to capture the 7,860 value from the website, isn't it? By, the initial idea is we open the website, we go get the information of what is the stock market today value, which is 7,860, and then capture that information in our in this activity. Is it not?
Yeah, only subtle difference here is that I'm aiming to actually get this table of data as opposed to that single value. But yes, you're right.
Oh, okay. Got it. Go ahead. Thanks.
Right. I'm just taking some slight detours just to explain a few of the sort of concepts around it. But yes, that's the ultimate aim of what we're doing. So this isn't particularly necessary. I've got an if and a debug. I don't really need to do this. But it's just to show you the sort of conditional logic as an example. Now, one other thing on the if is it's worth noting that you can write C# style syntax directly into this if condition. So, for example, if I wanted to, instead of checking where the element was found, let's say for some reason I wanted to ensure that the text was accept all cookies, then I can, again, I can write a C# style expression to evaluate that condition. So I can open quotes. I can inject my text, say if text equals accept all cookies, and we'll just check that we've got it's actually capitals like this. There we go. Then debug my value out, and again I can run this individually. You see, rather than running the entire activity, I can run individual steps. You see, indeed, it debugs that value. I can take the C# syntax one step further. So I think let's just check the syntax. C# lowercase. It's the to lower method. So let's just have a look at this. So I could say if text dot to lower is equal to accept all cookies. I say run this through. Let's hope my syntax is right. It is. Then you see again, I can output that debug value. So you see, in this case, I don't care about the capitalization on this text. I'm just taking it to a lowercase value and then evaluating it against this lowercase entity over here on the left. And of course, if I wanted to, I could take this value from another data chip somewhere else. So again, just things to be aware of. So let's move on. We'll look at grabbing that table of data now. So if I move into interactive and I scroll down, you'll see here's the table of data that I want to get to. So for this, I can again use my browser-based actions. We'll use extract table from browser. I'll give it a name, so we'll call it stock data. We'll select this table just by dragging. See, there's a common theme across these RPA actions. They all involve some sort of, broadly speaking, some sort of interaction with the screen. You can see it grabs that table. I've got options here as well, whether to include iframes and overwrite the table if it already exists. Critically, what I've also got here is an option to redact data. This one's a pretty important one. This option is here because I could potentially be returning a huge volume of data to my bot, and obviously that will take up so much bot memory. In this case, it's not a huge amount because it's a table that's only 100 rows large. And indeed, when you're doing most sort of manipulation, you do it in byte piece sizes. But it's important to know that redact data is here because if I take this activity ultimately and I put it into production, it's probably a good idea to have redact data where possible ticked, because it means it won't return all of this data to the console if I'm running it via the activity designer. And later, when we look at workflows, it won't return it all to the reports that run as a consequence of the workflow. So things will run a little bit faster, and it will keep sort of the performance of the system a little bit smoother. So another sort of important one to take a note of. So if I save and run this through, we can see it now. It's extracted the data, and you'll see that it's returned it here in a table. So you can see it's grabbed the epic and charted that, and the name and the price, etc. And just to show you what redact data does, if I save and run this through, it will basically revoke it as a result from the console. So the data is still there, and I can still interact with it and manipulate it. It will still work when I run the activity ultimately, but it will keep things cleaner. So redact data is probably something you want to do once you've finished developing a piece of automation, is go through, find any table-related actions, for example, and redact the data there. So we'll leave that unticked while we're developing. Okay, and we can see that table. So there's a bunch of things we could do with this table. Now, again, I'm going to take a slight detour. Ultimately, what we want to do is use some sort of filtration or analytics to clean up this table and spit it out into a data store so that we can store it persistently. But what I'll do is we'll take a slight detour, and I'll show you some of the table actions that you can use to manipulate tables and iterate through them. So if we look over here on the left, here's our tables group. And the first thing I'd like to do is show you how to filter the table data inside of an activity. There are a couple of ways to do this, but the easiest way to do it is with an action called get table data. So get table data allows me to data chip my table. So in this case, it's coming from the result of my extract table from browser. And it allows me to apply filters on the data that it returns. So in this case, for example, I might like to filter this data down so that it only returns stocks that are a positive with a positive day change, for example, here. So you can see there's a bit of a mixture. These are looking pretty negative today. Market's not looking fantastic. But I'd like to filter down because I'm an optimistic guy. So I just want to pull down the positive values. So to do that, I can implement a query. And if you are familiar with SQL, this should be pretty familiar to you. So you can see I can select the column and I can say, find me all rows where the day change is greater than 0, as an example. Again, all of these fields are data chippable, so I could be taking this value from elsewhere if I wanted to. I'll show you an example of that in a moment, actually. And you can see I'll save that, and I've got day change greater than 0. I can sort the values that come back, so I could sort them by the day changes in ascending order, for example, and then by the name. But I won't bother doing that here. I can limit the number of rows to bring back and the number of rows to offset in the query as well. Again, all data chippable, so you can do some pretty powerful stuff with this action. And again, you'll see that there's the redact data option down here, which I'll leave for now. So if I save and run this through, you see it runs get table data. Oh, it's errored. Operator cannot be applied to operands of type string and string. And it's throwing that error because it recognizes as it's pulled it here, it's pulled that column and it's recognized it as a string type. So I wonder if we can amend that. One way potentially to amend it is to use the data processor. So let's see if we can use this. So data processor will come back to in a mo. It's a pretty powerful tool. I'll pull my table through here, and we'll do some formatting, and we will change the data type. So I'm going to I'll come back and show you how to do this more rigorously in a mo, but I'm going to take my table, in fact, not my table, maybe just a specific column. Let's do the day change. And we'll change it to a float. And in fact, I can take my entire table and just apply this to the day change column. Okay, it's not much appears to have changed. Let's save and run that through. Okay, so there's my data type. And now if we try and perform, we get table data on this instead. There's my filter. Filter's the same. Let's see if this works. No, it's still spitting it out as a string. Okay, so we can't do this directly. We'll look at other ways of getting around this in a moment then. So instead, let's look at a different type of filter then. So let's take our table down, and we'll look, instead of doing a day change greater than 0, what else could we do? We could look for any rows that have a B in the name, as an example. So this time we'll try a query. We'll try name is like. Again, this is SQL syntax. So I can use my wildcard here. So I can say name like anything that has a B in the name. And so the wildcard is saying match any name where anything followed by a B followed by anything is valid on that name. So let's try this. There we go. And it runs it through. And you see, yeah, lovely. It's bringing back all the stocks now that have a B in the name. Now, what I can also do is I can combine queries. So what I might like to do is say, find me all stocks in this table row that have a B in the name and contain PLC. So I'm looking for companies that are explicitly marked as PLC. So to do that, I could come back to my filters, add another element to my column, to my query. So name like percentage PLC. Right, PLC percentage. You see, I'm making sure that these are linked with an and. Then I can accept this. So see, it constructs my query. I can run this through. And hopefully it's finding stocks now, which have just got PLC in the name. Dinesh, you got a question?
Yeah, Ben. So once we grab the information, can we also push to a physical table to record this information which I grabbed from the? So I'm just imagining that every day I have to go to this website, grab all these information, store it into my internal tables, so that I can use it in my workflow or any of the processes. Is that possible?
Yeah, so we'll look at persistent data storage in a moment when we come on to look at the data store. Yeah,
we can persist the information as well.
Yes, okay. Yeah, okay. Exactly. Yeah. So this is everything that's, yeah. So it's a good point you raise there, which is that everything we're doing at the moment is sort of in bot memory, and it will rise and fall with the running of the activity. But if we want to store it persistently, then we can do that with the data store. Yeah.
Okay.
So that's the filtration. You can perform more sort of complex queries here. So I could, for example, also look for, I could use the OR operator here. So I could say, find me stocks which have, let's say stocks which have a B in the name and the letters PLC. And we could group these. And then I could say, or find me stocks which have a name containing a C, and where the name is not equal to, Beasley PLC. I can see down there, Beasley PLC, and I can combine these in a group as well. Let's do that as an OR. So what this is saying is I've now got two group sections to my query. So this is now saying either in this first group, find me a stock which fulfills these criteria together, name like B and name like PLC, or find me a stock whose name has got a C in it, but whose name is not equal to Beasley PLC. So you see, I'm sort of separating out these two sections of my query. So if I save and run this through, maybe I have, have a look. What doesn't it like? Name like B, name like C. Something it doesn't like in my syntax here that I'm probably missing. But this is the basic idea, is that you can construct these more complex queries if you'd like. Okay, so that's grabbing data and filtering it with an action like get table data. You can also update rows of data, but we'll come back to that in a moment. So let's have a look at storing this data now persistently in a data store. So I'll park this for now. So we had a look at the data processor very briefly. Let's interrogate it a little bit more thoroughly. So I've got my table, which I've extracted here. And you can see that there's a couple of things about this data that I might like to change. So the first thing is that I've got this unnamed 5 column over here on the right, which I might like to remove. Okay, it's just saying deal over and over. It's not particularly informative, so I don't really need that. And I've also got this day change, which I'd like to shave the percentage off so that this is recognized as a number type when I pull it through to my application later. So in order to do that, we'll use the data processor we just had a look at. So in addition to the sort of the table actions, which we stepped into here with get table data, the data processor has a huge variety of functions that you can use to manipulate the format of data, filter it, and perform sort of statistics and analysis on your data sets. But it sort of springs in a slightly different environment. So if I step into the designer here, I can add, again, a bit like data stripping, I can add the result of my extract table from browser to my data processor. You see, there's a slightly different environment now. I've got a set of functions up here, which I can use to now manipulate my table. So you've got input and output. So you could read table data from a CSV or an Excel file, read it in from JSON or HTML. You can also write SQL queries in here. So if your bot has access to a SQL database that you'd like to push and pull data from, then you can execute SQL queries here as well. And you see you can also push data from a tabular format out into any of these formats as well. You've got filters here, a bit like get table data that you can use to filter your data. You've got operations, analysis, a whole bunch of elements here. So what I would like to do in this case is I'd like to first remove this column. So I can go to alter table, remove column. I can data chip my table from the input to the data processor and then name the column which I'd like to remove, which is this unnamed 5 column. So if I step back, you can see I've got my table here. Now remove the column. You see that column's correspondingly disappeared. Next thing I'd like to do is remove those percentages. So we'll use a different function. We'll use the remove function inside of text manipulation to do this. And I'll take the output from my remove column and I'll tell it to remove any pluses and any percentages using regex. So regex, if you're not familiar with, is a standard sort of pattern matching tool, which you use across a variety of sort of languages. So you can see I'm using it here to say match on these pluses and these percentages. You can see as well, if you pull this drawer up from the bottom, you've got some documentation as well on all of these functions as well to help you along. So I'm going to remove those plus and percentages, and you can see it's done exactly that. So if I look at my remove column, I've got the percentages here. And if I look at my remove step afterwards, you can see it's now removed those percentages. You saw earlier there are ways to format the data, so I can fill missing data and round data in here as well. And doing this, I can target, for example, specific columns of this data set with all of these operations. So if I just wanted to say filter or round the day changes here to 1 decimal place, what I could do is do a round numeric data. And instead of taking the entire table from my previous step, I can use the editor to select just a single column. So you can see the editor, I can select a given cell. I could select a row or a set of rows, but in this case, a set of columns. But in this case, I'll just select this data change column here and insert it, do it to one decimal place. You see it returns me, in this case, it's worked out that it's a column or a list, and it's done it like this. You can see if I pulled the whole table through, I could have chosen specific columns to format here. But I've done it like this just to demonstrate that you can use this sort of editor to select specific rows. So what I could then do now is I could alter the table. So I could say update the column of the remove. So I can say take this table, update the day change 1 column, and update it with the list that I produce with my round here. You see it now overwrites that column, day change 1, with my rounded values. As I said, not the best way to do it. I could have pulled the entire table through over here and formatted the column in a single step, but this just shows you how you can grab, say, a specific column of data and manipulate that, and then say, update it here. Okay, so we've got a pretty clean table now. As I said, there are some other functions here which you can explore, so definitely worth playing around with all of these. The last thing we need to do now to expose this table inside of our activity is to output the value here. So we'll give it a meaningful name. We'll call it filtered data, like this. We can save the activity as well. And now we can run this data processor through. You'll see it executes pretty quickly. It's built on Python, Pandas library, so it's very fast. And it's now produced the table with the rounded values for the day change. And also it's removed that column as we wanted there as well. Okay, the next thing that we'll do is we'll store that data persistently, as Dinesh alluded to earlier. So in order to do that, what we'll first do is we'll close down our browser. So we will close our browser down. So close browser. We'll also tidy up our activity. So I'm going to move this close back here because we don't need it once we've extracted the data from it. The other good practice here is to group your actions so your activity is easy to read. Obviously, as you're developing, like with any coding, it's easy to understand what you're doing, but it's not always as easy for someone else. So a couple of good practices here are to first group your actions. So you'll see if you look for control, you've got a group here. You can also search for the group using the search panel. Drag this in. And I'll give this a meaningful name. So I'll call this open browser and extract data. I can drag all of these elements in. You see that to move the elements into the group, what I'm doing is dragging here. In particular, I've got to be careful here because I can drag this action into the group. And if I drag it one further, it'll actually drag it into this if statement as well. So different levels of nesting for different items. We'll drag that close in. Now if I expand and contract this drawer, you'll see it's quite neatly nesting all of my actions now. So this is becoming a lot more readable rather than having a big long activity here. You can also, by the way, switch your activity to a condensed view. It's worth knowing. So if you right click, you can condense all of the actions here. This will give you a sort of a fuller view of everything that's going on. You can also, if I enable it on my profile, which I will do now. I can also enable comments and head back to my automation. And I can also now, if I right click on any action, I can add comments to the action as well, either for my own benefit later on or for the benefit of anyone else that picks up my automation. So again, if you've got a more complex piece of work that you're doing, worth doing this for your peers. So I've grouped it. I've given the group a meaningful name. And now what I'll do finally is add a data store. So we'll call this persistent storage. I can use an existing data store as well. So if I've got other projects that I'd like to pull data from, I can share data across them that are currently on for now. And then if I return to my activity, as a last step after this data processor, we'll find our variable group, which we'll come back to after our break. We'll find set data store variable. I'll select my persistent storage data store, give this a name, set the type of the variable. And so I've got options here for strings, numbers, booleans. I want a table. And I can now store my filter data as a table type into my data store. And again, just to keep things neat, I'll group this. So I'll call this filter, parse, data, and store in data store. And drag these underneath. And so now I've got my activity sort of finished, and I can run the entire thing through. So you'll see you can watch the bot perform all of those steps. It'll open up the browser, go to HL, really rapidly, close the notification, grab the table, process it with a data processor, and set that data store variable. And have a look back at my persistent storage. I've got my stock data over here. It's stored persistently. So even if I, now that this activity stopped running, I've got a copy of this data, which I can now access from other elements of my automation and other activities or projects, or indeed inside my application as well. Okay, let's move on then. So we've looked at tables, we've looked at sort of creating them, manipulating them. One thing that's worth mentioning as well is how to iterate through tables and how to update them. So we'll build another activity to do this, given that we've got our data stored persistently now. So imagine that we want to loop through each of our stocks and conditionally perform some sort of update to each stock, depending on some condition that we decide on. So we'll call this modify table. And this time, instead of assigning a GUI bot to this, I'm going to use a stateless bot because I don't need a screen. I don't need to interact with the screen. I just need to manipulate some data. So modify table. The first thing that I'll do here then is iterate through my table. So in order to do this, I'll go to my tables group. I'll go to data. And you see I've got this for each row option here. So for each row, again, I can data chip a table. In this case, I've got no tables in my activity, but I can go to my data store and I can find my stock data table up here. Again, if I'd like to, I can filter the data at this point that comes back and is used. So I can use the same filters, but we'll leave that back for now. And just show you what this does, I could say, again, do a debug value. And I could just say hi, like this. Now, I know that there are 100 rows of data in this table. So actually what I'll do off the bat, I'll be able to do it here. We could restrict this to columns where the epic is it bar for Barrett? Let's have a look. Barrett development, bdev. Cool. Let's filter this then. So for now, we'll just filter these to find them where the epic is bdev. So this should return one row. If I run this through, you can see, yeah, it returned a row and it said hi because it found one row. If I was to modify this now, so if I was to look for Cardo as well, let's say, OCDO, I could either add an epic under here, or I could say epic in bdev ODCO. Cardo CDO. So again, using different operators here, but this is saying is the epic in this list. And if I run this through, hopefully I will see it iterate twice. So it says hi, and then it says hi again. Now, I've shown you chipping. So I've shown you how to data chip. So take entire sort of elements or variables and pull them from one place to another from earlier actions, or in this case, from the data store. One of the other sort of important concepts in the platform is subchipping. So what I'd like to do here in particular is for each stock that I iterate through, I'd like to extract the current price, for example, so that I can perform some conditional logic on it. And so in order to do that, I can use subchipping. So let's remove this. I will remove my filter on my table as well. So I'm getting, let's keep it for now. We'll keep it limited to 2 rows. And the first thing we're going to do here is set a variable. So this is something that is a piece of data that will persist for the duration of the activity. Variables should be familiar to anyone that's got any sort of coding background. It's something that doesn't, or that can be modified. You create a value and then you can modify it later. So we'll add a variable here. Again, I'm going to drag it in and nest it under my for each row. And we'll call this current price. We'll set the type to, we'll leave it as a string for now. And the value, we will subchip. So what I'm going to do is, let's just save this for now. We'll run this through to pull the data so that we can see it. And in the value here, I'm going to click on my for each row. I'm going to step into my table with this little arrow here and open up this JSON path selector. And now what I can see is each of the rows of the table that it brings back one at a time, I have access to the epoch and the name and the current price and the day change as a percentage in a static value. So this is what I call subchipping. Instead of grabbing the entire entity, I'm stepping into it and I'm extracting a specific field. So I could, for example, extract the current price here. So if I select that, you'll see it brings that data back. And if I now clear the console and I run this activity through, you'll see it first sets the variable to 359 for the first stock it found, and then sets it to 44885 for the second stock that it found. Just going to remove my tea bag from my tea here. Lovely. So I've now extracted a specific field of this data. Of course, if I wanted also to get the epoch, for example, I could get the name, I could get the name. So I could subchip again, and I could get the name, for example, instead. And again, if I run this through, we'll see it iterate twice. It pulled back 2 rows. So first sets the name to Ocado, using the current price of 359, and it then sets the price to 448.85, and that's without developments. Now, what I'd like to do is conditionally perform some sort of action based on the current price. So I'd like to say if the price is higher than 400, then print something out to the console. And so I can do that. So again, if I go back to find my flow control group, indeed I could search for these actions. I can find my if, I'll drag it in here, and I can say if my current price, which I'll access through my variables tab, if my current price is greater than 400, then we will debug some value out to the console. So we'll debug, yay, that's the console. And so if I clear the console down now, I run this back through, you'll see it iterates twice. And in the first instance, it ran that if, but it didn't meet the condition. And in the second instance, it did meet that condition and it debugged yay, because it got all excited about the high stock price. So that shows you how to iterate through data and do stuff. Now, something that would be useful to do here is to maybe update a field of the table to say, update it based on this value. So what I'm going to do is I'm going to add a column to it, to my table, and we'll call this notes. We'll update it like so. So you can see this notes column is now blank for all of my stocks. What I'd like this to do now is to update the rows in the table if the price is greater than 400. So that debug, I'll go back to my table group. We'll find data manipulation, update table rows, and we'll drag that in. So we'll say, I'd like to manipulate this table. The row I'd like to update is the row where the ID of the row, which is uniquely assigned to it, is equal to the current row's ID, so whatever row I'm currently on in my iteration. And to do that, we'll just need to run. Let's just run, disable this mode. We need to run the action to actually expose that data chip so that we can sub-chip it, so that's worth noting as well. And now we'll do that again. So we'll say ID equals the current row ID. We'll grab that using, again, that sub-chipping capability. And I'd like to update the notes to say yay. Now what this is doing now is it's stepping through each stock that it pulls through, setting the current price and the name. It's looking at whether the current price is greater than 400, and it's conditionally updating only that row of the original table. And so if I clear and run this through now, again, what we should see is it didn't run the first time, it did run the second time. And if we go back and we look at our table now, we should see yay in the notes for our Barrett Developments PLC stock because its price is greater than 400. So that's update table rows. You can use update table rows not only to manipulate, obviously, data store tables, but also local tables. So local tables being, for example, our extracted table here. So you could iterate through it, a local table using this chip here, and you can update values in it and do all sorts of manipulation as we saw before with get table data. So worth noting this is all here as well. Okay, let's move on then. So the next thing that I'd like to look at is we'll move on and we'll have a look at workflows. Basically, and then we'll come back and we'll look at APIs as well. In setup for that, what I'm going to do is illustrate the inputs and outputs. At the moment, all of the sort of data that's driving each of these activities is pretty static. So, for example, I've got a static URL here. And what the inputs and outputs allow me to do is, at runtime, inject data into my activity. So let's say that, as an example, I wanted this get FTSE data activity to be able to grab data not only from the FTSE 100, but also say, I think it's the AIM 100, hopefully. Way to look for one of them here. Let's say FTSE 250 as an example. So let's say I wanted to either go and grab it or the AIM 100. So let's say I wanted to either grab data from the AIM 100 or grab it from the FTSE 100. In order to do that, I need to vary the URL that I pass to the activity. And so at the moment, this is very static. It's just doing it for a specific URL. In order to do that, I could add an input to my activity. So I could add a text input called URL, or just to be really clear, website URL. I could give it a default value if I wanted to. Let's give it this one, for example. Let's see, 100. And instead of having it statically injected here, I could data chip it again from my input and output tab. And so now when I run this through, it will still go to that URL, but it'll be driven by whatever input I pass the activity. So if I now vary this and do the FTSE AIM 100, you'll see now the bot opens up to the AIM page instead. And hopefully, provided that the formats of the two pages are very similar, it will grab, in this case, some slightly different data for the IAM stocks. So the inputs are really useful. As I said, you can think of activities like functions. You can vary the behavior of those functions by passing different data in. Any variable, so anything that's subject to change, so any inputs are automatically created as variables. And we saw that when I created a variable here, my current price and my name, they also appear in the variables tab here. So any variables will appear in pink, and then any action results, so you see the green ones here, are marked in green. The key difference between these, obviously, is that a variable is something that you can consistently update. So as an example here, let's say I run this through, and let's say I've not got any rows. Let's try that again. Filtering on. Oh, it's overwritten with the AIM data, that's why. So let's modify this back. And we'll do the FTSE 100 again, and I'll illustrate this. So obviously the two stocks that I filtered on were no longer in the table. So if I run this through, yeah, it's going to struggle now because the ID doesn't match. But I've got my name here, Venkat, and let's imagine that I want to perform a couple of manipulations to this, right? Let's say I want to remove any spaces in it and then set it to lowercase. Now, I could do that using a couple of actions. So if I look for text, I could do a regex replace, for example, to remove the spaces. So I could grab the result, the name here, and then remove any spaces, replace them with a blank. Okay, so that would remove all the spaces. And then I could additionally, do a text transformation. And we set it to lowercase, and I could take the result of that regex and then split it into a lowercase result. Okay, so I've now removed the spaces and removed it to lowercase. The problem with chaining like this using the green chips, using the results, is that if I now remove this regex replace and I run this activity through, it will throw an error because the text transformation is looking for the regex which I deleted. So it's no longer manipulating the name, even though I no longer want to use that regex replace. It's no longer manipulating it because it was relying on that result. So what I can do instead, the advantage of using the variables is that instead of pointing the manipulations at the green outputs, I can point them at the variables. And I'll do the same for this one. And I'll make sure that I tick update variable each time I do a manipulation as well. And now if I run this through, okay, you'll see it works, bar the update table rows, which is unimportant here. Even if I remove this regex replace now, this still works because it's pointing at the variable. So it's still, you see there, it's still taking it to lowercase. So variables are useful for storing sort of state, I guess, while the activity is running. And then you're not relying on this like chain of actions to update specific bits of information. You'd use them in exactly the same way you would in program. And that's differentiated by green for the results and red for the variables, pink for the variables. Okay. So we've looked at browser manipulation. We've looked at pulling tables, manipulating them, filtering them, iterating through them. We've looked at sub-chipping using that sort of arrow and the JSON pathing. And we've also looked at inputs and outputs. I think what we'll do now is we'll move on and we'll look at the workflows and it will sort of answer your question, Dinesh, about how to run things on a schedule. So we've got our activity. Let's add a workflow. This one we will call, grab data. And we'll create our workflow. We'll add a start node. Okay. We'll add a stop node. And we'll drag our get FTSE data activity in here. We can now connect these up like this and save the workflow. And now this is something that I can just run by clicking. So as it starts, it runs the activity. In fact, it gives me a preview and it then stops. Now, it doesn't look at the moment like much has changed from running this in our activity, but in fact, two things have changed. So the first is that now that I've got this workflow, I can either trigger it dynamically from an app or schedule it. The second thing that's changed is I now get a report of anything that was run on the platform. So you can see even after this workflow is run, this grab data report will persist on the platform. So I can always step back into this and view all of the steps that were executed as a part of that activity. In particular, I can also see any job arguments. So I can see, say, inputs to the activities that went in. And if I'd created any outputs, I'd see any outputs here as well. And you can see it around the draft version of my activity there. Now, what I'd like to do is schedule it. And so to do that, I can step back, add a new schedule. And let's say I want to do this on a daily basis. You see no published workflows to schedule. So actually I'll go back and publish my flow. There we go. Switch back to draft. Now if I add a schedule, I can run this. So I could say repeat on a daily basis at, I don't know, 1 a.m. or 1:59, why not, on a daily basis, and do that until the end of this week. As an example. So that now sets the schedule, and that grab to get the FTSE data will run every night at 1:59. I'll disable it for now, just to make sure it doesn't run. So that's one method by which you can schedule the automation of your activities. Now, obviously, inside of your workflow, you can also chain activities together. So I could add one here to do that table modification. And I could save and publish this. And now if I run this workflow, it will run first the activity to go and get the FTSE data, and secondly, the activity to modify the table. And again, if I look back at my report, you'll see it ran this one first and this one second, and then it stopped, and everything was hunky-dory. Now, the other sort of things that you can do inside of a workflow then, in addition to chaining your activities together like this, is to introduce some sort of routing based on your activities. So one thing I could do here, for example, is I could modify this activity to grab the current market price. So if I do that get web element, I'll add another get web element here to grab this price. I'll get data. We'll run that through, and you'll see it will return the price up here. And I can now output this price into my workflow. So I can add an output. I can grab that price, and we will call it price, like this. I'll save and publish. And now what we should have now inside of our workflow is access to that price, which we outputted. So here in the workflow, what I can say is if the price is greater than a certain value, move on and modify the table. Otherwise, stop the execution of the workflow. And so to do this, I can use my exclusive node. So this allows me to route my workflow. I can drag to connect, and I'll drag another just stop down here. So you see I've now got these two routes as a result. And in my exclusive node, what I'll say is if the price is greater than, set this a bit higher than the price, 8,000, then proceed to modify the table. Else, flow down this route here. Of course, you could add more branches if you wanted to, but I can save and publish this. I can run this workflow now. It will get the data. It will extract the price. It'll hit this decision node, or maybe it won't. Let's see why it's failed. Error, parsing invalid character 44. Potentially because I needed to output it as a number. So let's try doing. Yeah.
Both are not in same format, right?
I can't hear you, Venkata. Sorry, say again.
Both are not in same format, right? 8,000.
They're not. So I'm struggling to hear you. Mike's really quiet. Oh. Okay, I'll move on. Apologies. So I can instead check to see if maybe the value is exactly the same. Let's try this. So if the price is this, move on, it might be that it doesn't like the price that it's pulling, but we'll see. There you go. So it is. It's because one was the price was a I decided to output it as a text value. But of course I need it as a number to do that comparison against. So you can see here now, if we look at our report, it does the FTSE data, it compares the price to that value, and it decides actually that, yeah, it will modify the table in this case. Of course, I could invert that expression. So I could say if it's not equal to this, then that value, then modify the table. And this time we should see it flow down the alternative route after it executes. I've not quite got something. I've cleared, or maybe the price has changed slightly. But yeah, that's how you can route your workflows like this. Now, what I'll do just to, well, we'll leave this for now. So that's the start node, stop node, the exclusive for routing. What you can also do from within your workflows is trigger other workflows. So if you've got another workflow in here and you want to sort of sequence them to run one after the other, then you can do that as well. You can also set the reporting level. So you'll see when I look at the report over here, I get a full breakdown of every activity that ran, every action that ran, and I can even see all of the sort of the full details that are produced as a result. But actually I can restrict that because it's pushing out a lot of data to the pipeline and storing it that I don't necessarily need. So if I reduce this down to just say the actions level, and I say publish and run this workflow again, then we'll actually see that this report tells me which actions it runs, but doesn't actually allow me to step in and view any of the details. I can restrict that further. I can reduce it down so it's just showing the nodes of the workflow which run. So if I save publish and run that through, we'll see that it just shows me get FTSE data. I can't click into it, exclusive, and then modify table. And if I wanted to, I could go one step further and only ask it to show me the errors that are produced as a result of that workflow. But if it doesn't error, it won't report anything. So if I look at the report now, you see it runs grab data again, but it doesn't actually report anything out because there were no errors to report on. So using the logging levels is important, again, just to limit the amount of data that's being stored persistent on the platform when you don't need, you don't need to see all of the details every time any one of these flows runs, especially if you're running it on a scheduled basis. Now, other things that are worth noting here, we've got the same sort of indicators to say whether anyone else is looking at this. We've got the draft and publish states. So again, you can use the draft state as your development version, and the publish state, which I keep pushing up to, is your sort of immutable version that runs on schedule or is triggered elsewhere. And you've also got the ability to save a screenshot if the automation fails. So if, for example, this get FTSE data were to fail because the website had changed, then it might be useful to have this enabled so that we could see why. And finally, as well, we've got the ability here to send an email notification. So I can say if the workflow fails, send an email notification, and by default, it will send that notification to whatever this notification email is over here in your profile. Okay. So we've covered the nodes, we've covered the routing, we've covered the reporting and the error logging levels. Next thing to look at is how to trigger this workflow from an external system, or indeed set it up so that it can be triggered from an application. So,
quick question, Ben. So
yeah,
we have the option to share the activity across the applications, right?
it's limited to this project. So any activities are restricted to this project. So you can share the project with other users on the platform. But the activity itself is limited to this specific auto training project. The data source can be shared between projects, but the activities are sort of lockdown.
Only within the app.
Say again.
So the activities can be shared only within the application, not other application. I mean, not other project.
Not other projects, yeah. So you can sort of run them, which we'll have a look at in a moment, via the workflows from an application. But they, yeah, as far as the editing them goes, for example, then yeah, they're locked down to a specific project. Okay. So what we'd like to do is, as I said, is enable, make it possible to trigger this workflow from an app ultimately, or from another system. And there are two ways that we can do that. So the first way is a listener. A listener is just an API endpoint that immediately returns a success message if it manages to trigger the workflow that it runs. So let's create a new workflow. We'll call it trigger me. Okay, and we'll make it very, very simple. Start and stop node and an activity here, so get FTSE data. And to add a listener, all I do is I click on the start node, and I've got the option over here to add a listener. So I could name this trigger data pool, for example, give it an API key so that it's private and it can't be called publicly. If you don't do this, then anyone in theory could trigger your workflow. So probably I want to set an API key. And then you'll see what it's doing here as well, is it's looking at inputs to my activities and automatically populating them here. Indeed, if I wanted to add more, I could. But you can see in particular, it's asking for this website URL so that I can vary this each time the workflow is run. So if I save this now, you'll see it creates this listener, and it's giving me an endpoint that I can call, and also a request body that I can populate if I'd like to call this from another system. So if you're looking to, say, pull data from another platform and then trigger a process in Toca to sort of extract and handle that data, then you can use the listeners exactly to do that. And just to show you an example, if we open up just a piece of software that we can use to call the API here, hopscotch, I can add a request here. So I can add a post request. I can grab that URL, and I'll add a body. So grab that request body that Toca is giving me as an example. Just find that slightly. And then I could say, ask this, to get the FTSE 100, or I could vary this from whatever system I'm calling to say, go and get the AIM data instead. But if I send this now, you'll see it successfully triggers. I get a response from Toca at success, returns 200 OK. And we'll see if we look at our reporting dashboard that trigger me was run, and it was triggered by a listener. If I want to as well, again, I can step into the job arguments and I can see what inputs were provided to that listener when it ran. So there's a very, very useful and quick way of triggering entities or triggering workflows inside of Toca. And we'll look at it in a moment, as I said, in how you can then use this inside of the applications to trigger workflows on the back end. In addition to the listeners, what you also have in Toca are connectors. Now, each environment comes prepackaged with these basic connectors for different methods, so post, delete, patch, put, and get, as well as upload. But you can create your own connectors inside of the Toca development kit. So it's probably not something we'll look at today, but it's worth knowing that you can basically completely customize the API endpoints that you create inside of the platform. So if we look at an example of a connector, the advantage of using a connector is that you can customize the response that's returned to whatever system called the workflow. So in this case, this trigger me flow, when we ran it, we saw on hopscotch where we called this from that we just got a 200 OK back with a success message. But what if I actually wanted to get a little bit more information out of the platform? What if I wanted to, say, extract that price that I'd grabbed using my robotic process automation? To do that, I can actually use a connector instead. So very similar. I could start my flow, I could stop it, and I could add my get footsie data activity here. And I connect this up. But what I'll do this time is add a Git connector. So the Get connector, I will attach it to my start node. So this is the request node. So this is saying when this connector is hit, trigger the start of this flow. From here, I can also add a response node. So you see, I just drag a response off of here. And I could add this after my activity. And now I can customize this response so that it returns, for example, the price that I grabbed out of this activity. So now if I save this, you'll see I've got a connector. Looks slightly different. I've got this, this URL that I can grab here this time. And if I go back to a hopscotch, I can do a GET request to this, this URL. I don't need to provide a body in this case. It's just a GET request. And if I send this off, hopefully what we'll see is that it runs the flow in Toca. It'll take a second to grab that data, and you'll see it now returns the price in the body that it comes back. If we look at the pipeline, you can see that's exactly what happened. Here's our connector flow. It was triggered by a connector. No body was provided, but you can see some of the details of the call that was made into the platform. So you see what IP it came from, for example. You can see that it ran the activity and then it correctly produced that price result. Now, this is a very trivial example, but of course, you could actually use this to basically create, what you're doing here is creating API endpoints in Toca. So using these connectors, you can create GET API endpoints for GET requests and POST requests and whatever else it might be. So another example of that would be, what if I wanted to take the footsie data that I extracted and actually return that to the call instead? What I could do is I could say run this activity through again so that we can manipulate it here. And in addition to storing this data in the data store, what we'll actually do in our data processor is we'll also reformat this table to JSON. So I could take this table and I could do it as record types like this and output this value. So I could call it my JSON table and save and save and save. And if I run this back through, we'll see that in addition to the filtered data my processor was producing, it's now also producing a tabular, a JSON format. If I add this as an output as well, I can grab it here and I'll output it as a JSON type and save and publish. And now if I go back to my workflow, instead of returning the price, I can return the JSON table. And so if I save and publish like so, and I rerun my connector over here from Hopscotch, hopefully what we'll see is that instead of the price coming back, we get the JSON table. And indeed, that's exactly what we get. So we've got a list, and each JSON object is a specific stock with the name and the price and the name and the price, etc., etc., etc. So what I've actually managed to do here inside of Toca is take a system which didn't have any API endpoints for getting data, in this case, Hargreaves Lansdown, their website, and actually add an API to it or create an API over the top of it using Toca. So this is an incredibly powerful way of getting at data that you otherwise wouldn't have been able to with, for example, an API connection. So the connectors are extremely powerful. We've looked at an example of a GET connector, but of course you could use a POST connector as well. So if you needed to inject, you could inject data into Toca and then read it and conditionally sort of do something with it. Again, you're creating these API endpoints in the platform, and this is extremely powerful. Okay. I think that pretty much covers workflows. Any quick questions on that before we move on? Yeah, Dinesh.
Ben, you mentioned about, what you showed just now is basically the entire workflow can be exposed as a service.
Yeah,
Any third party can call that and grab all the information back there, right? So
yeah,
similarly, in my workflow, I need to call internal web service, which gives me, for example, claims information from a claim system.
yeah.
How do I, is that a web service which I can consume within this environment?
Yeah, so sort of do the reverse, right? Instead of having it call into Toca, call into it
Okay.
from Toca, yeah?
Yeah.
Yeah, great question. So let's have a look at exactly that. So we've looked so far at robotic process automation and data manipulation and workflows. Let's have a look at the API piece. So I've got an example here, down here. So this is an example of a project where, much like you say there, Dinesh, I've got some external data source that's accessible via API, and I want to actually, rather than push data into the platform, I want to pull data from that external system into Toca. So rather than use the workflow, what I can actually use is there's an action inside of the activity called an API caller, which does exactly what you expect. So in this case, I set a URL for the service that I want to call. You can see it's coming from this base URL, which is in my data store. Here's my site I'm going to, and it's hitting this specific endpoint. So I create a variable for this. And then I have an API caller here, which uses that URL, sends up some sort of body to that external service, and authenticates against it using an access token, which I've grabbed to then actually pull data into the platform. So if we first run another activity that I have over here to authenticate with it and store that access token in the database, here we go. I can now run this through, and you'll see it sets the URL that it wants to call. It makes that call using the API caller and returns all of this data. And I then work through that response. I grab it, do some manipulation to get it into a table, and then store it in my data store. And so what that allows me to do is the reverse, which is to pull data from an external service into a table in Toca. So rather than pulling it via RPA, pulling it via API. Let's break that down a little bit, actually, just some of those steps, because I think that's such a common pattern and that I think it's worth exploring a little bit here. So with we'll do this from scratch, actually. So let me add this here. We can use this as a reference. So let's get products from external API. Again, it can be stateless because it doesn't need to do any interaction with a specific screen. So the first thing I did was to set my URL. So I'll do set variable, and again, I'm using my search function just to speed up what I'm doing. So I'll set my URL. I'll inject that base URL, which I'm storing in my data store, and then add the endpoint that I want to hit. I've decided to split the base URL in this format, by the way, so that it acts as a bit of an environment variable. So if I move between, say, a live and a test API, then I can just change the base URL in one place in the data store and have it take effect across all of my activities. So I can set that variable, and that will set the endpoint that I'm going to hit. I can then add my API caller. So the API caller is found within I could search for it, but it's found within the API group down here. You can call API for, well, generic APIs, or a SOAP API caller if the system you're using is XML based. Select the transport mechanism, select the URL, which in this case I'll take from this variable that I set my method. So if in this case, I'm doing a post request because I need to submit a query to that API. Body type, I will do as text. And again, I could data chip this, or I could write it straight in here. Probably the best practice would actually be to set another variable before. called body, which is a JSON type. And then I can submit it this way. So I've got my URL, my body, and I can inject that body in. Content type of the application JSON, and I expect to receive application JSON back. And then I can use authentication. There are various methods here, but probably the most sort of familiar would be, say, a bearer token for this specific API, which in this case comes from my data store. So I've set all of this up. I can add other headers, by the way, if I need to here as well. And now I can run this through. Oh, I need to set the body and then set the API. And you'll see it returns some sort of result back. Now, one of the things that's worth looking at here is how I actually parse the data that came back. So this is obviously JSON, and a lot of the time when you're working with external systems and pushing data and pulling it via API, you'll be working with JSON. There are a whole series of actions here designed to manipulate JSON. Okay, so you've got actions for modifying it, for iterating through JSON arrays, like we did with our tables earlier, for converting XML to JSON, navigating through it and finding specific fields, validating its format, and also parsing it into other formats like a table. So what I'd like to do in particular here is find there is some sort of array here of products which I'd like to grab and parse into a table. So the first thing I'm going to do, just to see what I'm dealing with, this is something I do pretty commonly, is grab my data and pop it into a text editor like Visual Studio, just so I can see what's going on. Okay, so you can see here's my data that's come back from the API. So I've got a response, and then I've got this data field here, and this has all of these. Each product is in this field data field here, like this. So to get at this, what I want to do is use my JSON navigator. So it allows me to find a specific element of this JSON. So I can use my JSON navigator here. The JSON will come from the result of the API call. I want to select a single I want to select many entities here, sorry, because I'm expecting to grab an array of items out of my JSON. But if you're grabbing a single field, then you'd select one. And then the JSON query that I add here would just be standard JSON path syntax. Again, with the documentation that's being added in 7.5, this will all be illustrated a little bit more clearly inside each of the actions here. But JSON path, a little bit like the X path that we saw earlier for HTML, is just a way of navigating through JSON to grab specific fields of data. So if we find an example here, you can see, this, for example, you find guides all over the internet on how to use JSON path, because you can do all sorts of things. You can navigate through children, you can filter the data that you pull back, all sorts of stuff. In particular, what I want to do here, looking at my Visual Studio, is I want to get the field data for every item in the data array in the response object. So I'm sort of going to step through the response to the data array and then grab all of the field data of each of the elements that's in there. And so using JSON path, that looks like this. I do $.response to step into the sort of the highest level object here. .data to get down to this this array of items here, this data array here. I want to get every element, I want to target every element of that array. So I use that star notation here to do that. So I'm getting this element and this element and this element. And in particular, I want to get the field data out of this. So I want to get this field data object that's got all of these fields in it here. So if I save and I run this through, you'll see that JSON navigator now is just returning me an array. I'm going to do a new text file here. It's just returning me an array of all of those field data values. So you see I've gone from my unstructured format to a relatively structured format. From here, what I need to do is remove the spaces in the field names, because I want to convert this to a Toca table. So I can use a little bit of regex to do that. So we can do, if we find our text manipulation, we can find regex replace, and we'll take our JSON in, and we'll remove anything where we see a space, any number of spaces that are followed by anything that starts with a what do you call this, a quote. Anything that starts with a quote, with anything in the middle that then is followed by a quote and a colon as well. So this should target all of the basically it should target all of the spaces here inside of this JSON. So you see I'm looking for any spaces that have then the quote followed by this, like this. And so I want to remove them quite simply. So if I run this through, you'll see now it's removed all of the spaces. I'm going to grab this again, just to show you here. It's removed all of the spaces from those field names. So I had the model year, for example, here, and it's now removed that space. So that's a good example of using regex to manipulate text data. The last thing that I want to do now is take this data and convert it to a table so that I can store it. So you've got the JSON parser here, which I can add. I can turn this from JSON to a table. And run this through. And you'll see it now converts that JSON into a table. And it's able to do that because it can see that every element of that JSON array has exactly the same fields. So it's taking each of these fields and basically doing a pivot and turning them into columns. And then each of the sort of sets of values is then becoming each of the rows in my table here. So this is Dinesh, to answer your question, this is how you would, an example of how you would call into an external system with an API call, pull the data out, and then say, store it persistently in Toca. I could then do a set data store variable to store this.
Great, this is helpful.
No worries. Okay. I think that pretty much covers everything I wanted to look at on the automation side. Okay. Fine. Last thing to note before we move on is that I've been working sort of in isolation so far on my own. It's very sad on my platform. So it's just been me working on this particular project. But optionally, there are two things that I can do. I can share the project with other members of my organization. So if I wanted to share this particular project with Ben Roberts at Toca.io, I could say either that Ben's a co-owner of the project, so he can also set users and groups on who it's shared with. He has all privileges otherwise, so he can create automation and modify it and publish it. Or maybe he can just write it, or maybe he can just publish it, or delete it, or execute workflows, or just read it. So you'll see, for example, if I share this with Ben as a read mode, and I log out, and I log in as Ben. Logging as Ben here. You'll see if I filter what's been shared with me, you'll see this automation project here, and you'll see that I can see what's been done. But I don't have permission to actually edit it or modify it. So this way I can see what's going on, but I can't actually do anything to change it. So this is it's sort of useful to know. You can set, if you're working collaboratively, you can set permissions on what your team members are able to do based on their roles. Okay, so we've covered automation pretty comprehensively, I think. Let's move on to the apps. So applications in Toca, we'll start by creating a new app. And so put training, give it a name. You see I can generate these app flags here, but I can also just give it a name. So I can call this training or a URL. It's basically we're creating here 160424. I could add a favicon if I wanted to. So let's see if I've got a favicon ready to go. I've got this ammonite here I could use. There we go. Now you can restrict access to your applications. So you can either use username and password to do this, or you can use OAuth or OpenID, which will allow you to do single sign-on with services like Google or Microsoft. We won't have time to cover that today, but it's worth knowing that those options exist. So for now, we'll stick to basic username and password. We can allow users to register, and we'll add a login page in just a moment. Now, what is often pretty common is that you want an app to access data that you've sort of stored or used inside of your automation. So I could add what did we call it? I think we called it persistent storage. There it is, data store. And in particular, what I can do is set permissions on which app users are allowed to read and write to and from this database. So as an example, you can see with the default user setup that I've added to this application, I could say only authenticated users can read data from that database. Anyone that tries to read data otherwise will be unable. I do the same with listeners. So if I'd like to be able to trigger those workflows that I created earlier from this application, then I'll need to add them here. And again, if we did trigger data pool, which was our listener to grab that footsie data, I can set permissions on who is allowed to execute and see that listener. So again, I'll restrict this down to my authenticated users. There's a content management system, which we won't cover today, but like I say, with the updates documentation, that will all be explained very thoroughly. And once I've done this, I can now create my application. So first thing we can do is remove this default page because I don't want it. And I will add a new page to allow my users to log in to my application. So this will require authentication. It won't require authentication, sorry, because it's my login page. And this brings me into my app designer. So in analogy with the activity designer that we saw on the other side of the platform, the app designer is comprised of a canvas where you can create your app, and then a panel, in this case, not of actions, but of components over here on the left, which you can use to populate your application. So there are containers here for structuring the layout of your app. You've got charts here for charting data. Media is self-explanatory. And then typically or critically, you've got form components, which you can use to ingest data and send it to the backend. And then you've got some other components here, which you can use just to give your app a bit of body and a bit of life. So given the time that we've got left, I'm going to race through some of this. But if you do have any questions, then please do let me know as we go. So first thing that I'm going to do here is configure the theming on my app. So this is something that will take effect across the entire application. So there are colors and typography that I can use to modify how it feels. So if I can remember, I think I can remember E91E63, I think is the Toca pink. There you go. And for my secondary accent, I could just go white, like so. And I could modify the typography. So I could say use a Google font here and use Montserrat, which is the Toca font, like so, and use all of the styles, let's say. And there's some other options I could choose to employ here. But this will help keep things, get a little preview here, and it will help keep things consistent in sort of a static across my entire application. Now, the other thing I'm going to do is set my login page, given that I've just created it. So we'll set my login page here. And now what I need to do for this page is I need to provide some sort of form that my users can use to log into my app. So I'm going to add a flex layout here, which is a generic sort of container that allows you to structure content either vertically down your app or horizontally across your application. So we'll leave it in the content flow. We'll set the content so that it's justified and aligned centrally. We'll increase the width of the container so it's always the full width of the screen, and set the minimum height so that it matches the user's display height. And now what we can do is add a form in here, which we can allow the users to log in with. So we'll add a form to this page. The form type will be a user login form, and we'll redirect them to the home page once we're happy that they've logged in. We'll set the width of this to be, let's say, some fluid width. So let's say 33% of whatever the screen is here. And we'll set the background to be white so that it's sort of pops slightly off this grayish background. Then we can add another flex layout in here to structure our form. And in particular, what we'll do is we'll add some padding so that the contents of the form are moved away from the boundary of the flex layout. So if I add some padding here, you can see what's happening to the content there. It's getting sort of squished in. So we'll give this a little bit of padding. We'll also give, let's say, the corners a little bit of rounding, let's say 6 pixels. And we can add some elements to our form. So if we go back to our form components, we'll need a text field for the username. For this username, it's a required field, and we'll map it up to the username that's required from the form. And then we'll add another one here, we'll duplicate it and add this for a password, map that to the password field. We want that required as well, and we'll set the type to password here. Finally, for our users to log in, we need a submit button so that users can submit the form. So we'll type log in. You can see it's picked up that primary color from my theming that I set before. And in this case, let's say we could modify the typography to change the appearance here. So we could say, don't capitalize the text and set the weight to bold. Finally, in our flex, we'll add a bit of spacing between all of the elements. So I've sort of raced through that here, but the basic concepts are flex layouts can be used to set the flow, the alignment, the spacing, and the marginal padding in the application. And form layouts can be used in this case to log in, but to basically take in data and then submit it somewhere. In this case, it's sort of being submitted to the Toca authentication service. So if I preview this now, you see I've got a neat little login form that I can use to log into my app. Let's actually create an app user from scratch here. You could create a user registration form as well if you wanted to register users that way. But we'll add Ben to our application, or maybe Ben Roberts, Toca.io, and we'll assign Ben the authenticated group, but I could use whatever groups I wanted here. Add Ben to our application, and if we go back to our login and we preview now, I can log in as Ben Roberts, Toca.io, and hopefully, I don't know if there's a welcome preview. Yes, it did. It will send me through then to my homepage. So let's publish this application while we're here. So we've been working in the design environment for now, but what we'd actually like to do is expose this as a web portal that our users can access. So in order to do that, we'll deploy our application. First thing we'll do is we'll set our home page so that the access is restricted, because we don't want anyone just anyone accessing the app. We want our authenticated users only to access it. So we can set authenticated user group here as restricted access on the home page. And now I can deploy my application. Now, it's clearly unsaved changes. Let me step in and save those. And we'll hit deploy. And you can see it's now packaging that app up and it will deploy it out. And you'll see it'll be a little bit slower the first time it happens, and it will sort of speed up thereafter. But what it's doing here is it's taking all of these components that I've laid down here, packaging it into sort of HTML, CSS, JavaScript, etc., and then publishing it out to the URL slug that I set before. So you see this application is now accessible at apps.mercury.toca.cloud/ that slug that I set. And you can see it's automatically redirecting me to the login page, because if I try and access the home page, it will notice that I'm not an authenticated user and then kick me out to my login. So I log in now, Ben Roberts, Toca.io. I log in, you can see it takes me back to my home page. And now, of course, if I refresh this, I'm already signed in, so I don't need to log back in again.
Okay. Quick question for you, mate. When you package up an app, can that be shared with other people then as well?
So I mean, if I was to post this app into the chat here, let's see if I can do it. I mean, anyone can now access that app. So any of you could step and log in. Absolutely, yeah. By default, if you deploy an app like this, you see this is a default. We call them satellites, locations in which you deploy your app. By default, it will go out to this URL here, but it is actually possible as well to create and add deploy targets. So we can actually spin up app gateways or satellite servers elsewhere that you can deploy the application out to. So even if the core platform, say, was behind a firewall because you were dealing with sensitive data and you didn't want anyone accessing the configuration of your app, you could actually then deploy the application out to one of these deploy targets and have the application itself publicly facing, for example. So lots of options. In terms of the actual app itself, in terms of showing it in the platform, you've got exactly the same as you have on the automation side. So I can now share this with, say, Ben Roberts at Toca.io, my platform user, and again set permissions on what they're able to do. You'll see as well that because it's noticed that this app is attached to a workflow and to a data store, it will automatically apply any sort of shares that I make here to those projects as well. So sort of doing the work to cascade the permissions against the app. Okay, so let's actually populate our home page. One thing to note very quickly, actually, before we do that, is that I've been working in purely in the desktop view so far. But actually, when you build applications in Toca, you can the web applications, so you can make them responsive to different viewports. And so you'll see up here, I've got the option to develop for widescreen, for laptop, for tablet, and for mobile. Now, if I look at this application mobile, you can see that it looks a little bit cramped now, my login form. I think that's primarily because I set the size of the form layout to be 33% of the width of the screen. So your desktop is always your master viewport, because we assume that users broadly are creating apps to be used on the desktop. But if I want to make any changes, say, in mobile, then what I'm doing is applying patches over the desktop configuration. So you see at the moment, well, there's some things here that are missing. But if I modify the properties of this so that I set the width to, say, 75% of the mobile width, so it's a little bit more legible, you'll see it creates a patch on the configuration that I set before. So this is telling it, if this page is viewed in mobile, actually modify this specific property. In this case, it's the width, so that it appears like this. And so in this way, as you're developing, you can make sure that you're building responsive applications. In addition, the components that you choose over here on the left are important in terms of how they behave in different viewports as well. So if, for example, if we step back into desktop and we imagine, for example, that you wanted to use a grid to structure content on the page. So let's imagine that I had a grid here and it had, let's do another row, and it had, I don't know, say it had five columns on it in desktop, right? We can add some text in here. So I can add some text line there, like this. And then I could take this text and I could duplicate it across. You can do Control-C as well. So you can duplicate the components and I can drag them across. Like so. Okay, and I can preview this and it sort of fits okay in desktop. But of course, then if I view this now in mobile, some of these are looking pretty cramped now because it's the grid is sort of non-responsive. So if I'd instead picked, for example, a responsive grid layout, and I will do this in desktop. It's fine because I've deleted the I deleted it in mobile first, I think. So if I use say a responsive grid instead here, what you'll see is that the responsive grid is actually designed so that those columns will appear at different widths across the screen based on what viewport I'm looking in. So, you know, on laptop or on desktop, for example, I might say reduce the size of those columns so that we get, you know, 6 columns across the screen. But actually then, if I view this in mobile, you know, we could set this, in fact, 12 out of 12. And if we view this in mobile now, well, you can see that each of those slots is now taking up the full width rather than being structured in a sort of a column format. So it's useful, have a play with some of these components here just to experiment and see what best suits your needs. It depends, of course, what application you're building for, whether it's a desktop application or a mobile application or, you know, just a mix of the two. Okay, we'll remove that for now. I think I've accidentally deleted my submit button in mobile as well, which isn't fantastic, but oh well. It's fine. Lovely. Okay, so a couple of other things to look at. We've looked at layouts broadly. We've looked at the viewports. Let's look at how to pull data into the page. So on my homepage of the app in particular, what I'd like to do is present the table of stock data that I grabbed before. I'd like to add some sort of functionality to actually be able to click into each element of that data and view it sort of in full. So there are a couple of ways that I can do this. The first thing that I will do is add a nav bar here, just to give our app some structure. And we'll call this my data dashboard, for example. You'll see by default, it's giving me the option to explore all of the pages across the application, but you can set pages here so that they aren't visible in the nav bar. If you do decide to use this component, and you'll see it correspondingly disappears. So that keeps things a bit neat. You see as well the nav bar is picking up the primary theming that we set before, and I've got some other properties here for, say, I could, you know, add a logo here, for example, and add my Ammonite in as opposed to my data dashboard text over here on the right and the left. You can, of course, create your own sort of components. So instead of this using this pre-built nav bar, let's say I wanted to create my own for some reason. I've got a flex layout which I could add. I could set the height of that flex layout to statically be, you know, X large. I could set a different color, so I could set a green background on my flex layout. And I could then add some text like so, and I could say this is my nav bar. This is my nav bar, like so, and you know, let's set the text color here to white as an example. Bold, make it a bit bigger, and then I could probably set the layout here so that it appears in the center. So there you go. Now, if I want to create components like the nav bar, which I want to use across multiple pages, then it's useful to be able to create these, which are blocks. So blocks enable you to create a set of components once and then reuse it, edit it in one place and reuse it across multiple pages. So as an example, if I had another page here, let's say it was my contact us page, and I also wanted to use exactly the same sort of component on that page. I could copy it and take it from one page to the other. But actually, if I then edit one of those copies, it won't take effect across the other page. So what the block allows you to do, if I create a block here for this custom navbar, it will just take all of those components, and you see it's broken this out into a new tab inside my application. And now if I go back to my home page, you'll see rather than a set of components here, I've now just got my block. And so this is something that I can reuse. So I go to my contact us page, go to my blocks, and I can now drag this on and use it here as well. And of course, if I need to edit this block, I can now edit it in one place in this sort of tab in more detail, and then it will take effect across my entire application. So that's certainly worth knowing. In addition, what the blocks allow you to do is inject different data for each instance of the block. So as an example, if I wanted here to say, this is my nav bar, ooh, bit hard to see with the white text. Let's see where we are. This is my nav bar. You are on the something page. What I might like to do is tell the user what page they're on, right? So if you look over here on the right panel, there are inputs to your block, which you can configure. And I can add a page input with a default value of, I don't know, home. And so now what I can do is inject, again, using the data shipping, inject that value into my text down here. So I could say, if I click down here, I could say you are on the inputs page, you're on the home page. Again, we'll just style this so that it's bold and the text factor the color as well. Okay. And so now what I can do is on my home page, I can set that, I'll leave that input at its default home. And on my contact us page, I can set that input so that it says contact us. And so now as I move around my application, hopefully if I preview here, there you go, if I go to my contact us page, it's on the contact us page, and if I'm on my home page, it says home. Cool. So let's pull that data through then. So first thing I'll do is add a flex layout, and we'll give everything a little bit of padding, so it's spaced away from the boundaries of the page. We could also use something like a paper component to elevate our content. So we could elevate our content and maybe just outline it like this. There you go. So we're generating an outline there. We can add a bit of padding to that, whatever goes in there, and another flex inside. So just starting to build a bit of structure on the page here. And now what we'll do is we will add some data in. Now I want to present that table. Go on, Dinesh.
Yeah. Ben, is that okay if you can add a menu where we can call the same flow which we created, right, in a menu action, like a drop down or whatever it is, and then when we tap on that menu, it runs the workflow what we created.
Yeah,
and
we'll have,
shows reset.
Yeah, we'll have a look at that in a moment. We'll look at pulling data to the page first, and then we'll look at how to trigger the workflows in the back end as well. Yeah, no problem.
Sounds good.
Okay, so I've got my layout here then. So a couple of ways I could pull data through to the page. One obvious way is just to find a table component. So if I search for table, you can see there are a couple of tables here I could use, and I could drag this table in. Data source, I can again use this data shipping. You can see it's going to pull up all data sources that I've linked to my application when I set it up at the beginning. So persistent storage data store, there's my stock data table. And again, you'll see there's an ability here to add queries on this data exactly as I showed you in the back end. So I could filter the stocks that come through to the page by their name or their price or whatever it might be. But I won't. I'll set the limit of data to 100, and we could sort it if we wanted by the name of the stock in ascending order. And so if I save and preview this now, you'll see it pulls through the stocks in ascending order of name, and it's bolted on a search ability by default as well. So I could look for say Airtel. And if I wanted to, I could deliberately exclude rows in the table. So there's this ID or column, sorry. So I could exclude the ID column. And so I've now got a pretty neat table of stocks, which I can display inside of my application. Now, this table is a little bit limited in the sense that it's not particularly interactive. So it gives me the functionality I need to view the data. But if I actually wanted to, let's say I wanted to spring a small modal on the page with that data in a slightly different format, this table component doesn't give me any functionality to do that. So one of the very common elements that you'll use when you're developing any sort of tabular data from Toca and presenting in an application is the repeating layout. So the repeating layout iterates over any table that you pointed at and generates the same layout for that entity. So I might want to actually present this table as a series of cards, right, rather than a table, for example. And so what I could do is I could again select my persistent storage table with my stock data, and we'll do the same sorting. So we'll sort with the name ascending. And the display here, I can display it as a grid. So you see, again, it's giving me options for different viewports. I could say that I want the desktop column width to be 4. And then what I can do in here is generate the same layout for each of these stocks, but vary, obviously, the data that I show inside. So I could add a paper component again here. And I could set an outline, and I could give it a little bit of margin and a little bit of padding. And then inside of here, I've got complete customization over how I display any of the data coming out of each of these rows. So I could add a flex in here with, with a text component. And here I could add the name of the stock as a title. So if I step into my text now, I want to data chip the name. In this case, it's coming from the context of the repeating layout. So this is, again, an important concept to understand, is that layouts like this that are based on data generate context, which you can access. And you see the context I've got access to here, in particular, are all the various fields of the table that I might want to present or use. So in this case, I want the name. I can inject that into this text component, and it will display it here. And then now I've got complete customization as to how I format this. So I could set it bold, and then I could add a divider under here. We'll just give it a bit of space. And then I could say, add some more text down here in this card to say, you know, the current price is, again, context, current price, pence. Let's give that a bit of space. And the day change has been the day change, pence, and the day. Well, and then I could actually, again, I could select exactly how I format this. So I could say this day change in pence is day change percentage at 1.5%. Like this. And so now let's just tidy this up slightly. So it's like this and this like this. And now if I save and preview this, I can now present this data in exactly the way I want, which is to do it as cards, which the user can then click through like this, for example. Venkata, yeah, you got your hand up.
Yeah, hi. So I just want to make the grid as editable. Say I just want to add a new row, or I want to delete some of the row data, and I want to publish it back to database table again.
So I think the best way to do that would be to use, I'll show you how you could do that. You'd probably want to set up a workflow whose sole purpose was to take a specific sort of value and then submit it to a workflow which modified that row in the database. So we'll have a look at an example of that in a moment. Yeah. Krishna, hi Ben, instead of adding the data into the interactive table by the data store, can we manually add the data to the table? No, not really. So, well, there are a variety of ways to do it. So you might be storing that data in an in-page value, which we'll come to in a moment. But generally speaking, yes, you can. There are files. So we've skipped over the content management system, but you can create a content management system here, and you can add files here, and then you might be able to present, say, a CSV file inside of the application. I'm not sure if it would work directly. Generally speaking, you would, if I look at the automation project, you could upload a CSV here, for example, to your data store and then convert it to a table and then present it inside of the application. I think generally speaking, you'd need to have it inside of a data store in order to present it inside of an
Here in the
application.
data store, we can add, but in the table, can we edit that and add instead of the persistent key and data store?
So the table you would have to, I think it would have to sit, well, there are more complex ways of doing it. So you could take data input from a user and create a table in the browser that you then presented inside of here. But generally speaking, to present it inside of this, you could also, there are examples where when the user loads the page, you might run an activity in the back end that constructs a table and returns it as an output, which is used by the app. So it doesn't have to be stored in a data store, but generally you'd be using a data store table. Not always. It's a little bit more complex than, we won't have time to cover it in this session, unfortunately. Okay, so we've got our repeating layout here then. Now, as Venkat mentioned, one of the things you might want to do is actually use one of the advantages of having the repeating layout as opposed to this table is that I can completely customize the behavior of each of these elements. So in particular, to Venkat's example, let's imagine that we wanted to give the user some mechanism for updating some of the information in one of these sort of entries. How would we do that? So the first thing we need to do is create essentially an endpoint in our backend to modify the table. So what we'll do is we'll go back to our automation project and we'll create a very simple activity that updates stock data. And it's only going to do one thing. It's going to perform an update table row with the data that we provide it. So we're combining a few of the concepts that we've already learned so far. So in particular, it needs to know which row of the table to update. So we'll provide an input to our activity for that. We could call it, we'll call it ID, because we use the row ID. And then we'll also take a value, let's say that updates, we're expecting to update, say, the current price inside of the application. So actually, let's call it current price updated. Then in here, we can add a very simple manipulation. So we can update table rows in our stock data where the ID is equal to the ID that we take in from the app. And we'll set the current price to whatever. We'd have to do it as a number. So let's do the name just to keep things simple. Let's do name. Update the name of the stock. So again, modify our table where the ID is equal to the ID. And we'll update the name based on the input that's provided to this activity. We'll then create a workflow so that we can wrap this and have it call accessible from the application. So let's update stock name. That will be very simple. It will start, it will stop, and it will update the stock name, like so. We'll add a listener. And a key. So it's private, and you can see it's already pulled through the ID and the name here by default. And we'll publish this out. And now we've got a listener that we can use to update any stock in that table. So coming back to our application, we need to do a couple of things here to enable the user to, we'll use some of the in-page logic here along the way. So I'll demonstrate that as well. So in particular, what we need is we need a form here, and we need to set the form so that when a user clicks on any one of these stocks, the form opens up and it provides the option to say modify the name against this specific stock. So the first thing that we'll do is we'll add our form in down below, down here, and we'll add a flex layout inside so we can space the content. We'll add a bit of spacing. And what we'll do here is provide one input here. So I'm getting lost. So we'll use a text field here, and this will be the new name. And we'll want another input which contains the ID, but which we'd like to hide behind the scenes. So we want to submit it with a form, but we want to hide it so that the user doesn't necessarily see it. So to achieve that, what we'll do is we'll add a transition here. And we'll set this transition to collapse to 0 height. So we're hiding the contents that are contained within. We won't display it, but we will have it mounted on the page. And so what this is doing is it's creating a container here, which isn't displayed on page load, thanks to this collapsed effect, but which is mounted on the page. So the content in here is going to be submitted to the form. We've then got a text field in here, okay, for our ID. So now we've got a new name field and an ID field, like so. And finally, all we need is a submit button, which we'll add here, and we'll say, we'll call this update, like so. So now if we preview this, we'll see our sort of stocks up here, and we've got our form which we can use to update the name of any given stock. Now, we only want this form itself to be displayed when we click on any of these particular groups. So what we'll do to achieve that is we'll look at our Explorer so we can see the structure of the content on our page, and we'll place the entire form here inside of its own transition. And in fact, you can see here we need to pop the submit button just inside of the form, like that. So it's part of the form. So we need to nest this form layout inside of its own transition. So again, we'll go to our transition group. We'll drag it just above the form, and we'll drag the form inside. This transition, we need to be able to actually trigger. So again, we'll collapse it to 0 height. We won't show the form on load, but we'll give this a meaningful name. So we'll call it transition for form, for example. Now what we can do is we can use a button inside of each of the elements here to open up this form and default the name and the ID. So we will add a button here. Let's search for button. And we'll add it to each of the elements here. And we'll call this update name. We will set the style so that it's just text. Make it a bit smaller. We won't capitalize, and we'll set it bold so it's clear what it's doing. And this is where we can now move from editing components on the page, which is static, to actually introducing events. So introducing events is using what we call IPL, or in-page logic. And so what I'll do here is configure the button using this IPL so that I can trigger events on the page when the button is clicked. So we've got our button here. I can access its events via this little lightning icon. And this brings up, it will bring up an interface that's very similar to the workflow designer that we saw before. So what I can say here is when the button is clicked, you see there are a whole bunch of possible events that I could trigger here. But in particular, the one that I want is this trigger event listener. So when the button is clicked, trigger an event on the page. In particular, the event that I want to trigger, going to the event listeners over here, is the transition for the form. So I want, when this button is clicked, I want to trigger that transition and show the contents of the form. So I will set it like this, and we'll set it to show. So the data here is just indicating I could toggle it, in fact. So we can have a toggle, we can have it set, but we'll set it. So we'll say when it's transitioned, set the state of the transition to 1 or true, i.e. show. And if we wanted to hide it, we could set it to false or 0. But we'll set it to 1. We'll title this show form. And so if we save and preview this now, if we hit update name, you'll see that it then spawns the form underneath, like so. The last two things that we need to do here are default these values based on the item that we clicked, and then actually link this form to the listener so that it updates the correct row in the database. So to set the default values, you can see, as I mentioned, there are a whole bunch of sort of events that I can trigger over here on the left of my in-page logic designer. So I can do some of the same regex manipulation. I can execute JavaScript. I can make API calls and even execute listeners directly from, say, button clicks. But in this case, what I'd like to do is set an in-page value. So I'd like to set this so that when the button is clicked, it sets an in-page value in the user's browser that tells it which ID has been clicked. So we'll call this ID. The value will be coming from the context of the repeating layout. So remember that this button is inside of the repeating layout. And just like the repeating layout provided context here for the name, it will provide that same context inside of the IPL as well. So if we look at the value here for the ID, you can see I have access to that same context and all the fields of the table. So I can grab the ID, say, that's been clicked on. We'll set it as a string type, and we'll just store it temporarily in the user's browser. You can choose to do session or persistent storage as well. So we'll call this set ID. We'll duplicate this and do exactly the same thing for the name. So we'll do all this set name. The key we'll call name. The value, let's just call this selected, just to make it really clear. Selected ID and selected name. The value this time, again, will be the context and the name of the stock that we clicked on, string type, and temporary storage, and then we'll show our form. Over in the form now, I can default both of these fields to those in-page values that are set. So the in-page value is providing me with a way of taking data from one part of the page, making it global in the user's browser, and then using that data elsewhere. And in particular here, I'm using it just to default the values of these fields. So I've got the name and the ID. I can set the default value for the name. You see, I've got an option in addition to my data store, which I used earlier. I've got an option for the in-page value. It's a temporary in-page value, and you can see that it's suggesting either selected ID or selected name, which I've just set. So I can choose selected name for this one, and I can choose selected ID for this one. I'll disable user input on the ID as well. We don't want them to be able to change that. Bear in mind as well, this ID field is hidden because of this other transition that I've set. So don't be alarmed when it doesn't appear. And so now if I preview the application, and I hit update name, have I selected? It's because I haven't assigned this to a listener, but you'll see it's obviously doing something, and it's defaulting the form values. The reason it's injected the ID into the name field here is because I haven't actually set form inputs for either of these. So to rectify that, we'll add the listener to our application that we want to call. So we've got one for triggering the data pool. We want our update stock name listener that we just created. And again, we'll set the permissions on that so that any authenticated users can run that workflow. And now what that should allow us to do is map the inputs. We'll set the form layout, type as listener. We'll select that update stock name listener. And now I can map the inputs like so for the ID and for the name to the inputs of the workflow in the back end, which we set up before. I'm aware that we've moved through this relatively quickly, but all of this is available. If you look at the intermediate section of the community website, you should be able to get a good refresher on the layout, the in-page logic, and also the form submission. So don't worry if we can move through this a little bit quickly. So we've now got, we're in a position now where we're displaying the data. We've used some in-page logic to write data to the user's browser and trigger some other event on the page, in this case, a transition. When that form displays, we're correctly defaulting it with the values that we set in the user's browser. And we've pointed the form at the right listener so that it can run this workflow. So now if we save and preview this, hopefully this will work nicely first time. So we could say 3i Group PLC. You see it defaults with the current name. I could say add the word test to it. We'll update the name. And you see it completes successfully. Now, it hasn't updated the data in the page because I haven't told it to do that. So we'll come back and do that in a moment. But if we have a look at the report that ran, you can see it triggered the update stock name workflow for the app. And you can see it run that update table rows using the ID that it got from context and the name that was provided by the user inside of that form. You can see it says warm record updated. If we go back to our application now, we'll preview again, what we should see is that that name is updated. Now, the reason it didn't update by default is that when we selected the data source for the repeating layout, the update rate was set to -1, which is the default, so it disables any live updates. So we've got two options here. We can either set this update rate so it updates at a certain frequency. So we could poll it, say, to update every 10 seconds or so. Or if we wanted to be more efficient about it, we could actually use that same IPL to tell the layout to update its data once this form's submitted. So if this time I go to the form layout and look at the events here, I can say if the form submits successfully and the workflow runs, look at my data group, I can say refresh data chip, and I can point this at my repeating layout data source, and I'll ignore the filters on it here. And so what this will do now is every time the form successfully completes, it should refresh this data. And so if we save and preview once more, say we take Admiral Group, and I'll say Admiral Group test, we'll submit the form like this, and hopefully what we'll see, I've updated the maybe the table there instead of the repeating layout. One of the changes that comes in 7.5 actually is that by default, all of these data sources will subscribe to changes. So they'll subscribe to any changes by default, basically, rather than having to do this sort of IPL. But once we've made those changes, we can save, deploy our application, and then we'll get this packaged up nicely and expose this URL once more for our users to use. So that is pretty much Toca in a nutshell at a foundation level.